Have you ever stopped and wondered about how the world is engineered to keep you safe?
Good afternoon, everyone. Thank you for joining the last episode in our webinar series, The Future of Safety Science. This is the series that connects underwriters, laboratories, leaders in safety research and standards to the next generation of problem solvers. So welcome to the discussion. As Dennis said, there's a questions tab in your control panel on the right side of your screen. Please do send in questions throughout the presentation, as we really would like to hear from you. This is a really wonderful opportunity to connect with our stellar panel. Today's panel brings our 21-22 web series to a close with impressive individual and collective experiences. Over the last 11 episodes, we've learned about the safety of science through the work of our Research Institute teams and the engineering of a safer world through the vast work of safety standards. While we've touched on careers in each of our discussions, today is totally devoted to that topic. Our moderator is Ronaldo Borger. Ronaldo is Vice President of Human Resources at Underwriters Laboratories, a human resources executive with extensive international experience. Ronaldo is a trusted advisor to the executive leadership team and leads the development of people strategies to support the organization's mission and growth. Before joining the Underwriters Laboratories team, he most recently served as the Chief Human Resources Officer at Cimbria. Ronaldo earned a BBA from the University of Sao Paulo in Brazil and completed the Advanced Human Resource Executive Program at the University of Michigan. In addition to his certification as Senior Professional in Human Resources, he is certified as an Executive Coach by LHH and in Organizational Culture by Human Synergistics. Ronaldo currently serves as a board member for the Career Transition Center of Chicago. Thank you for your work and your time today, Ronaldo. I'll turn it over to you to introduce our esteemed panelists and begin the discussion. Thanks.
Thank you, Kelly, and it's an honor and really a pleasure to be here. We have a great group of panelists for one of the topics I'm most passionate about, which is career development and professional growth. I'd like to introduce one of our panelists, Chris Kramer. He's the Senior Vice President and Chief Research Officer for Underwriters Laboratories. Chris holds a PhD in chemistry from the University of Illinois. And prior to UL, he was the Vice President of Research at the University of Minnesota, in which role he expanded the institution's research enterprise into one of the top 10 public programs in the United States. We will also hear from Denise Durant, one of our engineering program managers at UL Standards and Engagement Organization. Denise has a Master's of Science from North Carolina State University and is pursuing her Doctor of Engineering and Systems in Engineering from the George Washington University in Washington, D.C. Prior to UL, Denise was in Research and Development Engineer in the Engineered Product Division of the Goodyear Tire and Rubber Company. We'll hear as well from Steve Kerber, the Vice President and Executive Director and leader of our Fire Safety Research Institute. He's a PhD in Fire Safety Engineering from Lund University in Switzerland. And prior to UL, he was at College Park, Maryland Volunteer Fire Department, where he served at all ranks from firefighter to deputy chief. And last but not least, Krista Wright. She's our Director of Toxicology in our Chemical Insights Research Institute. She's a PhD in Environmental Systems, Environmental Health Toxicology from the North Carolina Agricultural and Technical State University in Greensboro, North Carolina. Prior to UL, Krista was an assistant professor and an assistant professor position with Georgia State University, where she conducted consumer product safety research, along with teaching environmental health and environmental health toxicology. So welcome to our great panelists. And with that introduction, I actually would like to turn it over to you and ask each of you to introduce yourselves, not your roles, but your degrees, but tell us, I think we're very interested in learning more about what is the work you do today. So I'll go in reverse order and let me start with Krista. Welcome.
Well, thank you, Ronaldo, for the introduction. And it's a pleasure to be here to talk about the safety of science as well as career development, which is one of my favorite topics. In my role as Director of Toxicology, I'm responsible for developing a research program centered around determining the impacts of chemicals of concern and emerging technologies on human health. And how we go about that is trying to understand the chemicals and particles of interest and emissions that we are characterizing in great detail, but also using novel in vitro and in vivo model systems to accurately and holistically determine their biological and toxicological impact on various model systems that we design here in the Chemical Insights Research Institute. It's a pleasure to be here and a pleasure to speak with you all. Thank you.
Thank you, Krista. Steve, what about you?
Thanks, Ronaldo. Well, I've got the privilege of leading UL's Fire Safety Research Institute, and our FSRI team is dedicated to addressing the world's unresolved fire safety risks and emerging dangers. And what I mean by that is a lot of our current research focuses on, say, the dangers of the wildland-urban interface, where climate changes and how and where people build their homes is colliding in a way that needs to be improved. And as we see play out all across the world on a regular basis, there's a lot of work that needs to be done there. We're working on ways to improve the safety of where we all live and where the fire service works during an emergency. We know our homes burn faster than they have in the past, primarily because of the synthetic materials that we put in them. And this has led to an increase in home fire deaths over the last 10 years, and really a trend that we need research to reverse. It's also contributed to an increase in job-related cancer for the fire service, and we're conducting research to try and reverse that trend as well. And then the last topic I want to highlight is fire forensics and computational modeling. We're conducting research to improve the scientific understanding of how fire grows and spreads from the molecular level all the way to a building on fire, so that we can better understand that impact and reduce the fire burden around the world.
Well, thank you, Steve. That's really impressive. And I always share every day or every week I'm at UL, I learn about new things that we do and impressive work we do in safety science and research. So thank you for that. Denise, over to you. Tell us a little bit about your work at UL Standards.
Thanks, Ronaldo. So hello, everyone. Again, my name is Denise Durant. I work for the UL Standards and Engagement Organization. And 3 years ago yesterday, actually, our organization made the decision to really focus on advancing the technical rigor of our standards and documents. So what I love to tell people is, as the world advances and we're trying to keep things safe, our standards are a way in which we do that. We want to make sure that our standards respond to technology. We want to make sure that when Steve and Chris and Krista, as you hear more about their research, as they are coming up with new things for us to consider, that we figure out a way to translate that into our standards, whether it's the tests, the design requirements, or the examinations. We want to make sure that our standards are actually effective. And so with my role in the Standards and Engagement Organization, I lead a team of engineers, and it's a diverse team. We have electrical, mechanical, textile, materials, chemical engineers who are all looking at what I like to call the systems approach to problem solving and incorporating safety science into our standards and documents.
That's fantastic. Thank you, Denise. And Chris, how about you? What's your role as Chief Research Officer for our organization?
Sure. Well, for the bulk of my professional career, I have acted as a chemist, a theoretical chemist. So Steve mentioned the importance of modeling when one examines fire, for example, and modeling is also tremendously powerful in chemistry for making predictions about properties of molecules or systems or materials ahead of time, so that experiment, which is more expensive generally, can be prioritized. And I still do a tiny bit of that on the side, but as I'm a more senior person these days, I became interested in research administration at a certain point. And what does an administrator do, if that's the question? To some extent uses experience and networks that have been built up, connections, to try to make it easier for the people who are doing research in the laboratory, in the office, wherever it might be, to create an infrastructure that is especially favorable for them. You know, remove the challenges of assembling the right kind of equipment or laboratory space or information access, whatever it might be. And so I am lucky to work with great researchers like those who are on the call, and try to accelerate what they can do and make it better.
Thank you, Chris. And that's quite a career change. I'm sure many go that route, but tell us a little bit about how your education, your early career experiences influenced or informed your career path to get you to where you are today.
Yeah, I was really interested in science and especially in math when I was a young student in, you know, high school, if you will. And so I went to college with that intent. I was gonna, I started majoring in math and I picked up chemistry along the way. And, you know, maybe like many young people, my relatives all had strong ideas about what I should do with my life. And so I kind of went with the intent of pursuing a medical degree as a medical doctor, assuming that I could make that happen. And I got to the last possible second, basically, as a senior in college. I had applied to medical schools and graduate schools in chemistry and had acceptances from both, and, you know, had to make a decision. And happily, so here's a piece of advice I guess I would offer. You know, I had tried to take advantage of internships, cooperatives, the sorts of experiences that let you test out a field to some extent, if you will. And at some point, as I was pondering, I realized that the research I had done in dermatology, which involved going into Barnes Hospital at Washington University, that was a research lab, but you went through the hospital into a certain floor where you could do the research, always depressed me a lot. Hospitals, I found a depressing place. And that was informative as I realized that maybe a medical doctor shouldn't be depressed by hospitals. And so I ultimately chose to go down the professional chemist path. And I think that's probably served me well. I also had paid for my undergraduate experience by joining the Army ROTC, Reserve Officer Training Corps. And so after my PhD, I spent little over 4 years as an active duty military officer in the Army. And that was a tremendously useful experience in some ways too, prior to going to academia. As you know, there are few organizations quite as large as the United States military, and learning how large organizations work can be a valuable skill later on, as many organizations are large. And so I'll stop there and let others potentially chime in.
Thank you, Chris. Let me turn it over to Krista again. So Krista, how did your education and your early career experiences influence your career path?
Oh, great question. And I do believe that my education and training and where I obtained my education really influenced my career path. I went to one of the largest HBCUs, a historically Black college and university. In the nation, North Carolina A&T State University, and there they taught us how to do a lot with a little. And I took that, was engaged in my undergrad and also graduate research that I participated in my education, and really ran with that and realized that, you know, I can do a lot and I am valuable and my voice is valuable. And I think that in that development, in that knowledge gaining period, I really got a sense of self and also an understanding of how science is conducted. And I think that in that, it really focused me and made me really understand I wanted to obtain my PhD. I really wanted to be in charge and run research and conduct research at a high level. And so I did seek out a PhD program that sort of fit all my interests, including environmental health, environmental systems, how the environment, the built environment can contribute to adverse health effects, but also what and how those adverse effects can contribute to disease. And so through my education, I sought out different programs, volunteer opportunities that really contributed to my overall knowledge base. But then also one of the most influential experiences or opportunities I had was to conduct my postdoctoral doctoral research at Harvard School of Public Health. And, you know, in that setting, or moving up north past the Mason-Dixon line, that was my first experience dealing in another environment, a whole nother culture. And that, putting myself outside my comfort zone, really expanded my knowledge, but also my confidence in myself and my knowledge base. So I would think that, you know, my education, where I obtained my education, but also these interactions in between there really sort of guided my interest into environmental health toxicology, but just my overall interest in science and learning and exploring the unknown really drove my career trajectory, but also in, you know, I had the opportunity to interact with various organizations and universities to obtain my my education and my expertise. But I would say it's all about the education and my experience and those opportunities. Absolutely.
Thank you, Chris. I love how you said exploring the unknown, because that's both what you do every day in research. You're exploring the unknown, but also from a career development perspective, sometimes that's what we do when we jump into a new role or a new company or organization or field. Denise, what about you? Your early career experiences, how did they influence the role you're in today?
Oh, it's funny you should ask me that question, because as a young engineering student, I thought I had it figured out. I decided to get my undergraduate degree in an engineering major that no one in my family had heard of, textile engineering. And I thought to myself, oh, this is great. You know, this is a great mesh between, you know, what I'm interested in from like the chemical and the material side, but also looking at how you can apply, you know, fibrous materials in different ways to different applications. So back then, the whole enticing factor for going into textile engineers had to deal with wearables. And so that's what I was most interested in. My sister is a computer engineer, so imagine coming home and telling, you know, mom and dad, I want to go into textiles. So I think a lot of people didn't know what that was. And some of my earlier internship experiences, I would say, really kind of helped me understand what I wanted to do, because, you know, when you think about textile engineers, you end up in a plant most of the time. And plant life was not for Denise. And what that forced me to do was really try to figure out, okay, exactly what is it that you like and what you don't like, so that you can have a long and healthy career. And I ended up having one of my last internships that I actually got through the GEM Fellowship was with the Intel Corporation. And lo and behold, I got to go into a clean room laboratory setting, and I loved it. And with Intel, what I liked the most outside of the environment was the fact that the research that we were doing was cutting edge. You know, back then, this is 2006, but back then we were actually doing the research for the Pentium 4 processor that came out, you know, five or 6 years ago. So we were doing advanced research, and what enticed me the most was the fact that we had to think about not where technology is today, but where is it going? And from that experience, I would say that that really helped, you know, kind of catapult me into, you know, learning more about UL and underwriters laboratories and finding a home here, because the work that we do, even on our for-profit side, is all about making sure that, you know, the products and the systems that we come into contact with every day that are advancing every day keep us all safe.
Thank you, Denise. And you mentioned something that hit home for me is the idea when we're studying and thinking about what career path to pursue. It's not just about what I would like to do or what I think I like to do. You had the vision to think about, okay, what kind of environment am I going to be working at, and is this the environment where I'm gonna enjoy, that I'm gonna be successful at, and you kind of navigated your career path based on that. And Steve, what about you? I know you have a fascinating story. You started as a firefighter, you became a PhD, and would love to hear more about that.
Well, my story is kind of like Denise's, from the standpoint of I went into an engineering area that most people hadn't heard of. It's fire protection engineering. It's like, well, we know mechanical, we know chemical, nuclear, what is this fire protection thing? And kind of stumbled across it by accident at a counselor's office as I was looking at colleges at the time. And I had grown up in a fire service family. College was not normal in my family. So my grandfather was a mechanic and a volunteer fire chief. My dad was a carpenter and worked at a fire training academy. So I was in diapers crawling around fire stations as I was growing up, and through school was halfway decent at math and science and loved math and science. So found a way to kind of combine those things and stumbled across the fire protection engineering program at the University of Maryland. And at the same time as I was discovering that program, there was another program that really shaped me, which is that they have, instead of living in a dormitory, you could live in the firehouse. So if you live in the firehouse for free while you're going to school, it's like, all right, I can save some money. This is good. And I love the firefighting component. And I'll tell you that moving from the rural suburbs of Philadelphia to Prince George's County, Maryland was one heck of an eye-opening experience, and one that I am incredibly thankful for. But it really allowed me to see the impacts of fire and what it does to people, and that people side was really impactful. That really drove an interest to figure out how we can apply research to improve fire safety. So I would go to school during the day while we had career staffing at our fire station to cover the fire station. I learned the theory of fire science, and then at night we had a dormitory above the fire station where 18 of us college students essentially covered the fire station. So we'd go to thousands of calls a year and experience all kinds of things that make you question the theory, make you question what you're learning in the classroom when you see different things happening in the street, and try and make sense of those things. And the other thing that was a great kind of melting pot experience is the students came from all over the country. So they came with all kinds of different experiences from a firefighting perspective, and they all did things differently, which would kind of planted a seed of like, well, fire's not different in these other places. Why would the tactics to fight the fire be different? But it absolutely was, which has led down decades of research trying to understand why does it have to be different if it is different? The outcomes need to be the same. We need to give people the best chance of survival or prevent fires. And fire science was the common language to make all that happen. So it's been a fun ride, and now I can say that we get to burn things legally to learn about them to make the world a safer place. It's been a great path so far.
Yeah, I love the combination of the academic and the practical experience and how you merge the two. After that experience, as you either before you joined Underwriters or after, was there like a key moment or experience that kind of accelerated or significantly shifted your career path?
Oh, there's been many. The one I would really point to. So I worked in the federal government for a little while, and at the National Institute of Standards and Technology. And I think one of the things that always frustrated me was the lack of leadership training, the lack of you can know science, but you've got to be able to work with and lead people in order to be effective. And I think real turning point for me coming to Underwriters Laboratories was the commitment to continuing education. I was able to attend a global leadership program and an executive leadership program that both broadened me culturally quite a bit by giving me cultural experiences all over the world that I had not had and tremendously benefited from. And then professionally, I was able to get kind of a condensed MBA education from one of the top universities in the world. And like having a strong university education was a great foundation in science and engineering, but my experience in the fire service and that leadership education really taught me how to lead people. And I think that those are two really important components that need to come together. That being the best scientist does not automatically make you the best people leader in a research organization. And UL had the foresight to have those programs in place to make sure that our folks were getting people leadership opportunities that they could apply. And I think our research institutions are going to be world leaders because of that dedication.
Yeah, and you touch on something that is really important in career development, which is the combination of skills and talents, right? You can be incredibly deep and focused in one area, but the more skills you add to your knowledge base, the more you can grow and contribute and help others as well. Chris, how about you? One key.
Yeah, it's hard to point to, an epiphany of sorts, if you will, but I think that I would echo something Steve said, and that is that during my time in the military, which was very early in my professional career, that was sort of a stunning experience for me in the sense that I grew up in a small city in Wisconsin, not a very diverse place by any means. And meanwhile, the Army was fantastically diverse, and frankly is one of the organizations in the United States that embraced diversity earliest. And so I got to know lots of people from lots of different backgrounds, and the Army also pays very serious attention to leadership training at the earliest stage. And Krista and I both have experience in higher education where, as a faculty member doing research, you're leading a small group of individuals, typically students who are part of your research group, or might be in classes that you're also offering sort of practical training through. And I felt as though that leadership experience really assisted me in being a good group leader, and has continued to serve me well, because to some extent, when people are your tools as opposed to flasks, and as a chemist speaking that way, there's just so much more you can do when you help others achieve their potential as opposed to what you can do on your own. And that's some of the joy of being an educator, and some of the joy of being an administrator, is that ability to leverage what you know and help others to achieve that potential. So that's always given me an enormous amount of satisfaction, and I've continued to sort of pursue that route.
And for you, who was someone who influenced your career, whether a boss, a mentor, a colleague, the role you play for many today? Who was that person for you, and what role they played?
Sometimes people influence you by showing you what you don't want to be like. So I've known research advisors who were somewhat domineering, unpleasant, and sort of awful to work for, although maybe you could survive if you got to the stage of working with. So I always decided that was not a model I wanted to adopt. I kind of like service leadership personally. You're there to make others be better, as I sort of alluded to. But an interesting moment for me was at some stage I was the chair of faculty governance at the University of Minnesota. So, shared governance system at universities. And the provost invited me to lunch, which, I saw the provost from time to time, certainly, but didn't go to lunch very often. And I said, oh, well, sure, of course. And when we got there, he said, I really wanted to have lunch with you, Chris, because I think you have a talent for administration, and I think you should pursue this. And, maybe I'd given it a little bit of thought, but this forced me to think about it very carefully, and I did ultimately move in that direction. So I think that was, a wonderful thing on his part to take the time out and give that sort of direct message, which did push me in a significant direction. And I think, paying attention to the people you work with and helping them see those kinds of things is a very worthwhile effort.
Excellent. And Krista, what about you? Someone who influenced your career and made a difference?
Well, Ronaldo, I actually have two people, honestly. One is my mom. She's a 35-year-old teacher. She taught for 35 years, rather. And she always, every morning, she hit me with Winston Churchill's famous quote, never, never, never give up. And she would always drill that into me with any challenge I ran into. She was always there to support me and to tell me that I could do it and get through the issue at hand. But my second person is someone I ran into, and like Chris, he wasn't always the most pleasant person or mentor, but it was one of my mentors that really helped hone my skill set and helped hone my honestly my whole scientific approach, really. And that approach I've been using for years now, and I utilize at Georgia State, and I intend to utilize that here at Underwriters Laboratories. And it really is just a unique way of looking at an issue, at a question, at a scientific question, and then also developing methods around that question, and also imparting personnel that have the skill sets to address that question. And he just had this framework that worked really well for us. Although he wasn't a pleasant man all the time, the framework really stuck with me, and that framework is essential to have in any institute that you're working in, or any organization, is having a strategy, rather. And that strategy and strategy building is some concept that one person, my mentor, imparted in me, and that was an influential experience and mentor in person that I would say really drove my career to where it's at now.
That's excellent. Denise, what about you? Key person who influenced your career?
So, I of course I have to give it up to my parents, my mom and dad. At a very early age, it was all about focus and hard work and determination. So much that, my dad is in the military. So, and my mom is, you would think my mom was in the military as well, growing up. But in that environment, it was, again, all about hard work and determination and focus, focus. There's so much to learn, there's so much to do. Don't lose focus. And my senior year of college, or going into my senior year of college, I wanted to move off campus. And they said, no, you're not moving off campus, you're staying on campus. Focus, focus on school, you're almost there. And it forced me to, rebel a little bit. And I said, well, if I'm going to stay on campus, then at least let me find a dorm or a program that will, just make me not be so bored being a senior living on campus. And so I signed up to basically establish what my college called a living learning experience for students. And so I was a RA for the Women in Science and Engineering program. And the two professors that were over that living learning village, Dr. Laura Bottomley and Liz Perry, still my mentors today, because they were able to take these very technical topics and bring it down to a level where we would go out to different elementary schools and introduce kids to STEM. And I loved it so much that, they offered me a fellowship. They ended up getting funding from the National Science Foundation to continue their work. And they offered me a fellowship to go back to school, get a master's degree, and continue working with them on that program. It was called Ramp Up, and it stood for Recognizing Accelerated Math Potential in Underrepresented People. So during my graduate career, I didn't TA a undergraduate class. I actually got to teach Introduction to Engineering at a local high school. And the great thing about that experience was that, I couldn't go in there and teach them college level chemistry, although Chris may disagree that I was teaching college level chemistry. But I wasn't able, and really my purpose was not to go in there and teach them those concepts. The purpose was to introduce them to the concepts in a very different way. So we made ice cream, we built popsicle stick bridges, and we were introducing the topics as we were doing those experiments. And I would say what I learned from all of those mentors, Mom, Dad, Dr. Bottomley, and Liz, is that, there needs to be more focus on making sure that we not only have that pipeline development in place, because we need more engineers, we need more thinkers in the world, more scientists, more people going into those STEM fields. But in order to do that, we can't just have a pipeline, focus. What they taught me was that we need to have this garden, and that garden has different flowers, different people, different levels of expertise, different backgrounds that we can pull from, so that when we need a material scientist, we know who to go to. When we need a fire protection engineer, we know who to go to. And that was instrumental for me just going throughout my career, because it taught me that, even though I was the person in the room that did not have that mechanical or traditional electrical engineering degree, that my background and my experiences still mattered. And to this day, it's really caused me to, and really helped me understand, what it is and what I want to do in terms of my career and how I want to make an impact, which is why I'm back in school now.
That's such a great story. And you talked about the garden and the different flowers and different people and different backgrounds, which leads me to a question that I know it's near and dear to your heart, and it's to all of us. In what ways the elements of diversity, equity, and inclusion and working with diverse teams influence your career progression?
Oh, wow. I mean, huge. That's a huge topic for me because I think when we all think about diversity, equity, inclusion, sometimes our focus is on the people, but there's a huge focus on people. There's also a huge focus on experiences and leadership. And for me, when I think about DEI, what I always tell people is DEI is all, it encompasses all of those different things. So you need the right people. We need to make sure that we engage, a wide range of people, people that may not have an opportunity or access to information. If we can pull them into the fold, we can get key information that can drive the research, the standards that we're all developing and working on. And then, of course, as a textile material scientist and chemical engineer, I've got a lot to say about a lot of different things. And so for somebody like me, I want to hear from everybody. I want to hear what Steve is doing. I want to hear what Chris is doing, which I haven't had a chance to do yet. I want to know more about what Chris is doing because at the end of the day, for the work that we're doing in standards, it involves a systems approach, a multidisciplinary approach to safety science. So in order for us to solve those unresolved problems that are going on in the world, in order for us to tackle, the way technology is not only emerging, but even merging. There's technologies that are overlapping. There are things that are becoming more horizontal if you look at the environment and cybersecurity. In order to truly tackle those things, DEI plays a huge role in that because we need to know who to talk to. We need the right stakeholders at the table, and then we need the right people at the table who also have that background. So we can't have all of the software engineers like my husband downstairs. We can't have, nothing but electrical engineers. We need a diverse group of thinkers, and that's what I love so much about the work that we do at Underwriters Laboratories is our focus on safety science, which looks at so many different diverse areas, and it allows us to bring in so many different diverse voices and experiences.
Thank you, Denise. I really appreciate how you expand the notion of diversity into so many facets of what it can be. And Steve, how does that resonate for you? How does diversity, equity, inclusion play into your environment?
Oh, Denise said that so well. I was lucky to meet a colleague in Sweden very early in my career, and we both figured out we were researching similar topics, and we were both volunteer firefighters, and we both kind of like, hey, we're unique, but we're not unique. So he had the vision of creating this international group that would be, it was kind of like Noah's Ark. It's like, we're going to bring 2 people from every country and we're going to bring them all together, and we all have the same thing that we're interested in, which is research to make the fire service safer. And he built that network. He brought those people together. So while, we didn't look the same, none of us spoke the same language. It was, we would share ideas and everybody had perspectives and everybody was open to learning what everyone else was doing. But we had that common fire dynamics language. The fire didn't care whether it was in the US or Japan or Europe or whatever the case was. So we had that to fall back on, but everything else was different. And then every year we would go to a different country and that country would host, and we would get to see their culture. We would get to see why they developed the way they were. And that allowed us all to reflect on why we were the way we were. And we all took so much away from that had nothing to do with fire science at the end of the day. But it was really that group taught me the value of all of those DI principles. And it was, to this day, we're all dear friends and frequently reach out to each other and bounce things off of each other. And I think one of the big things that got developed was, it was almost like everyone checked their feelings at the door, because everyone knew there was no poor intentions, and a lot of things got lost in translation a lot of times, but everybody knew that was the situation. So everybody looked past that and got to know each other as people, which opened up so many other dialogues that really, I mean, it's had a lasting impact on me, and something that I hope to pass on to my team here is to give them those networks, encourage those networks, so it can break down some of those misconceptions or misunderstandings.
That's great. It's a great story, Steve. Again, expanding the concept of diversity and inclusion. And Krista, I saw your head nodding there. So what resonates for you?
Yeah, well, Steve's story resonates with me a lot. I mean, it reminds me of experience I had in graduate school, in which, you know, I was a part of a diverse team there, but it was more so diverse in regards to the disciplines that we all held. But in that, you know, opportunity and in that experience, we sort of realized, hey, we all have other opinions and also, you know, experiences that can contribute to our issue at hand. And in this sort of experience was with this engineering research center that I was a part of in my graduate school work. And it was a collaborative of clinicians, material scientists, environmental scientists, and other engineers. And, you know, it seemed like we were speaking different languages, but we were all supposed to be brought together, similarly to Steve's concept that he mentioned earlier, to address one common goal, and which was to reduce the toxicity of various nano-enabled materials that we were developing. And we continually had this issue of, you know, whose voice is the most important, and whose voice, or which path should we go down? Should we go down the toxicologist path? Should we go down the clinician or the research scientist? And I think in that moment, it made me realize that we all had valuable insight to provide to this issue, but how do we, you know, normalize it, ensure that we all have equal voice in the situation, in this situation, and from that, I think we gained you know, a respect for each other's discipline, but also a respect for the diversity that we all can bring to a situation that will help us address that issue. And I think ultimately we did lead to a great product, a finished product, a product that's actually being in phase 3 clinician studies now. And I think that diversity in that engineering research center really led to that major accomplishment with that material that we were developing. So I think diversity definitely is the solution to a number of our challenges that we are facing today, and also challenges that we are not too aware of. I think diversity is the key.
Thank you. And that's a great segue to the question I wanted to ask. How do you see in your work the connection between safety science and the work you do and diversity, equity, and inclusion?
So yeah, there's a huge connection there. I mean, a large part of products that affect some of our most vulnerable populations are due to the lack of safety testing and the lack of oversight in product development, product stewardship. And so I believe that, you know, understanding the most vulnerable populations' issues, concerns really are important in safety testing and in product development. I do believe that the reason why we have so many products that are out there is that we're not listening to our constituents or listening to our consumers that are, you know, bringing up concerns or issues that they have with various products that they utilize on a regular basis. And we should sort of start trying to understand how different communities and different populations may be impacted by environmental concerns or environmental hazards that we actually can control now, but of course we know has not occurred. But I do believe that having a diverse range of input into product development and safety testing is important so that our vulnerable populations are protected.
Excellent. And Chris, I know this was probably a big part of why you came to Underwriters Laboratories, and the role you took is to make that connection. So how do you articulate the connection between safety science, diversity, equity, and inclusion, and the work you're doing?
Well, I think Krista made the excellent point that, when you look around, certainly American society and even globally, there are tremendous sort of inequities and potential biases in the way different groups are affected by technologies, the health experiences that they have, which certainly is within the realm of safety. And when one sort of asks the question, well, why? How did that develop? Especially when we have all the science and technology that in principle could address it. And it's not too hard to come to the conclusion that, unfortunately, science and engineering are fields that have historically been very poorly diverse. And so if you don't have members of the community who are adversely affected participating in the discussions about how to address those problems, you may not even recognize those problems are there. And sadly, there's also been a tendency, I would say, historically, for scientists and engineers in particular, to sort of lean back and say, we're meritocratic. We're not biased. We just, assess things through the lens of science or engineering. But that's a alluring but false argument, because it just sort of accepts the status quo. There must be biases in the system because we have a system that manifestly exhibits bias. So in the absence of doing something proactive about it and removing whatever barriers have been put into place, whether conscious or unconscious, we'll never get to the stage where meritocracy has any meaning. And so I think that that's really a critical aspect that continues today. And Denise expressed it well, I think also, that we need to begin recruiting at the very earliest levels to make clear to people of all sorts of backgrounds that their abilities may contribute tremendously to these fields, and we need all those voices together. So that's the sort of thing that I'm passionate about doing and trying to assemble diverse teams.
Very good. Denise, I know you wanted to touch on this question as well. So what's your point of connectivity, safety science and diversity?
Yeah, it's funny because with safety science and DEI, when you look at the standards that we develop, a lot of times we're identifying, product safety hazards, and we're trying to figure out how our standards can mitigate the risk associated with those hazards and the products that the standard is actually covering. And it takes me back to my early career at UL and being an engineer, a certification engineer, working with life jackets, personal flotation devices. So everything from what you see toddlers wearing at the lake to what you see U.S. Coast Guard workers wearing their full gear when they're out for a rescue. We do it all. Our standards cover that full range of protective gear. And what we noticed is that early on, we were focusing so much with the standard really just assessing, 6 subjects or 18 test subjects. We would bring people in and have them test, different products that were coming in. And it was clear that the standard probably did not have enough detail in there to truly cover the diverse populations that utilize a life jacket. Even down to the size ranges, not everyone is 6 feet tall, 150 pounds, down to, male versus female. And so now where we are with standards is we're really looking at, things like gender responsiveness. For a life jacket, for example, not only do we need to test males and females, we need to test kids. We need to make sure that when we're testing, 18 subjects for something like an inflatable device, that we're not just testing people that wear inflatables every weekend when they go fishing. We need to get and make sure that the standard addresses the fact that, hey, there's some people that have never come into contact with an inflatable life jacket. And as such, we need to make sure that when they do, they know how to accurately put it on. Not everyone's going to read the warnings. Now manufacturers are transitioning from, markings and labels that are, physically placed on the product or on the packaging to, oh, we'll direct you to our website. Well, how effective is that if that person doesn't have, internet access? So we're thinking about all of these things to make sure that safety science is incorporated into the work of standards development. And the DEI portion is making sure that we're not leaving anyone out, because everyone is impacted by all of the different things that our standards cover.
Yeah, those are really, really great examples. Now we're getting close to the end of our time. So Steve, this was a great discussion about STEM research, safety science, diversity. If you are graduating today and had the knowledge and experience you have, what would make you interested and excited about STEM today, and what advice you would have for our audience?
Well, first off, if we can figure out how to take our experience that we've collectively gained over time and somehow get it into our graduating students so they could just stand on our shoulders right off the bat, that would be the most amazing thing in the world. So I think that if we can start figuring that out, or how to speed that up, I mean, that's, I think what I would get excited about, and really what still has me excited about the work we do, is the magnitude and the complexity of the problems. And we need so many smart people to tackle these problems. In the grand scheme of things, fire science is a relatively young science. So there's so much more to discover. And at the same time, the new challenges evolve. I mean, such about the wildland urban interface I talked about earlier, that are so complex, so interdisciplinary, are going to take all the things that we've all talked about to work together in harmony to make some progress. And I mean, other things like battery failures, where new technology advancements create new fire safety hazards, and we're going to need the next, latest, greatest, smartest STEM folks out there to tackle these problems. So it's not standing still at all. We need young folks that can run faster than I ever could. And God, I wish we could get the experience component. I think the education component is really good. If we can find a way to get the experience piece to speed up, so we don't repeat some of the stuff we've done in the past, I think that would be tremendous.
Thank you,
Could
Steve.
I jump in after Steve? I'm sorry.
Yes,
Could
please.
I jump in real quick? I just to add to Steve's comment about bringing in people and making sure that we have, you know, the next generation covered and ready to go. I think, you know, one way to solve that, or to address it, is to create internship programs here in UL. I'm not sure if we have that yet, being a newcomer. I've been here about 6 months now, but I really am passionate about training and mentorship. And I think that having internship programs which reach our youngest base and try to, you know, sort of bring them in earlier, as Denise was saying earlier, creating that knowledge and that awareness early on is crucial to setting up our next generation. And I've developed programs like that at Georgia State, where we, you know, bring in the youngest to really make them aware. And I really think it does make a difference, absolutely. But to the question as well, you know, what would make me interested today in a career in STEM is all the neat technology that they have now, like CRISPR, gene editing tools that they have. I mean, if they had that, you know, developed when I was coming up, I would be so excited about being able to manipulate genes and change the course of someone's health early on. I think that would be, you know, one thing that would draw me into STEM if I was graduating college. But it's also interesting today anyway. But yeah, I think that's basically where my interest lies. It would still be in science, still be in STEM if I was graduating today.
That's fantastic. Denise, what about you?
Oh gosh, I would say, you know, you can never stop learning, because like I said earlier, there's so much that's out there right now that we don't know enough about. And then some of these areas are you know, cross-pollinating. So what I would say to those of you that are in school right now and you're listening and you're trying to figure out, you know, what are we all talking about? What we're saying is that we're all very passionate about the work that we do to truly make the world a safer, more secure, more sustainable place. And that's not a cliche. It's kind of what we live and breathe every day by the work that we do. And so learning those fundamentals is great, because that's going to impact the experiences that you have in your career. Those fundamentals, you know, I've been there. I was thinking to myself, you know, why do I need to know this? But it comes up later. It translates and pops up in places that you'll never imagine in your career, on top of the experiences that you bring to the table. And all of those things coupled together, in addition to, you know, continuing to learn and continuing to evolve, all of those things are really going to play a huge part in a very successful career for all of you.
Thank you, Denise. And Chris, I'll ask you a different last question here. It came from our participants, and it really resonates with where we're trying to go with Underwriters Laboratory. But for you, what in your role, what kinds of activities and initiatives you think are more important as we try to drive global impact of our safety science research?
Sure. Yeah, that's a super important question. And I think there are sort of two aspects that are really important to think about. One is that, of course, we call ourselves a research organization, and research means discovery, new knowledge generation. But you have to recognize that just because you've discovered it, you can't just sort of toss the bread on the water and hope that you did what you needed to do. Others will pick it up. It's really important to recognize that you need to communicate to multiple audiences besides just professional peers, for instance. Publication in a professional journal is a traditional way for advanced researchers to speak with one another. But if you want to have an impact on society more globally, now there are literally dozens of different audiences who you will need a differently crafted message in order to reach. And so it's critically important to have communication, amplification of your results, and targeted at those different audiences, which certainly include K through 12 school students, undergraduates, for example, changing curricula on the basis of what you've discovered. So that's super important. And I think, and incidentally, Kelly, who's still lurking somewhere listening to this call, is the person who leads that effort out of my office at Underwriters Laboratories to try to do some of that curricular change and engaging with students and interns, as Krista mentioned. And the other aspect is to recognize that, fundamental research often discovers fascinating new things. But if you aren't also putting effort along the applied spectrum of research that ultimately connects probably with industry, you will never be able to take a product or a development, what have you, to the scale that would be needed if it's an actual, a device or a change to a technology. It's manufacturing at scale that's going to be required in order for it to really affect people out in the societal environment. So paying attention to translating technologies and transferring technologies to the private sector, which often is the one that's best able to then leverage that up fully to scale, is equally important as you plan out a research path.
Excellent. Well, thank you, Chris, Steve, Denise, Krista. It's a pleasure having this great conversation with you. We're at about time, so I'll turn it back over to Kelly Keene, our host.
All right, thanks everybody. I was lurking and listening, and I could not be more enthusiastic about this discussion and what it offers to our up and coming problem solvers, the next generation of problem solvers that get to dig into these complex, wicked problems that we're all faced with. So thank you for a fantastic way to close out this academic year in this series. In reference to the discussion, we do have a new office for research experiences and education and have a lot of plans and are really thinking about all of these pieces. This is going to inform a lot of that work as it's being drawn up. So stay tuned for that. You can follow us on ul.org. In STEM education, we often talk about the need to create direct, meaningful conversations with leaders who are doing the applied work and the administrative work and the important work. Today and throughout this series, we're so grateful for the leaders and your time to do just that, to create these really direct conversations for a lot of people who are looking for this. So thank you very much. Recordings of our past webinars as well as this webinar can be found in the link in the chat that Jess will drop in and on ul.org. You can also find us and this whole series on YouTube under the Future of Safety Science. And we're not done. We are wrapping up this season and preparing for the next academic year. So keep an eye out for an exciting email announcement about our season 2 lineup, and that will also be on our website, ul.org. Well, thank you everyone for your time today, and thank you most of all for the work that you do. It's important and critical, and we can just hear the passion that you have for your work and for, like I said, this next generation of problem solvers. Happy spring to everyone and best wishes for the end of the academic year. Really wishing you all a restful summer. We will be sending you a survey to see what you thought about this and the series, so keep an eye out for that as well. All right, be safe. Thanks, everybody. See you all again in August. Take care.